Intro to the Theory of Computation. Test 1, 2, 3. That's probably good. I think that's good. Maybe a little quieter. Test 1, 2, 3. Test 1, 2, 3. Alright, good enough. Alright, let's see what Leetcode's made of these days. Well. Okay, I think that was just a quiet song. Oh wait, before I do that. Does this work? Okay. Looks pretty good. Hey, Solaris. Long time no see. I know, I chopped it. I cut it all off. Well, my girlfriend did. I told her, let me know when it's time. And she came to me on Thanksgiving and she was like, it's time. You need to buzz your head. I was mostly... Let me get a look at myself. Did I lose a bet? I guess she thought I looked better this way. And afterwards I was like, I don't think my hair was that bad. I don't want to pull up a driver's license that has like identification stuff on it, but like, I thought actually my hair looked pretty decent. It was like thinning slightly, but mostly I'm just really thankful I don't have like a weird egg head. Like I was really worried about being this guy. I was concerned I would have this head shape, but luckily it looks okay. And like the way I act and the clothes I wear, it works out. No dent like Tyler 1. Oh yeah, I was gonna... Yeah, here we go. I like having little Easter eggs open. Some people look, they're like, what the fuck does Tyler 1 dent mean? How have the Leetcode contests been? I haven't done Leetcode contests in months, probably. I mean, I haven't done an actual live contest in over a year, maybe less than a year. But I haven't even done a virtual in months. I've just been doing Codeforces. And then, like, I've just been kind of studying, like, Olympiad questions and stuff. I actually haven't used Python in a while, so this is going to be weird. In a string S consisting only of characters 1 and 2, you may delete any number of characters from S without changing the order of the remaining characters. Return the largest possible resultant string that represents an even integer. Okay. Can I do this? Is that how it works? Or what do I do? Like this? Okay, that works. That dot join A, while A. And what happens if it's just empty? You just don't return anything. Okay. While A, you'll be AFK for 30 minutes, okay. And A at -1 is equal to 1, A dot pop. I think that's how it works, right? Fuck. That's right, it's colon, not parentheses. 1112, 22, that looks pretty good. Okay, off to a good start. Word squares to string array words consisting of distinct 4-letter strings, each containing lowercase English letters. 6 to the 4th, so 500k in case I need that. I can just generate every single distinct thing. A word square consists of 4 distinct words. What? Top, left, right, and bottom. Top forms the top row. Bottom forms the bottom row. Left forms the left column. Right forms the right column. Must satisfy all that stuff. Return all valid. I see. So it's not like it's not a filled-in word square. It's an empty word square. Sorted in ascending lexicographic order by the 4 tuple. Okay, let's do that. Is this sorted? It doesn't cast it to some weird object. No, it looks good. Oh, word set length is only 15. So couldn't I just try every single combination? A word square consists of 4 distinct words. Is the input distinct? Yes. Okay, we get all 4. And then we say, I'll just say if check A@I, A@J, K, A@L, res dot append. Oh, but then I need it to be like, okay, well then I'll just have check be a void function. It's not really going to check. It's going to check, and then if it's valid, it doesn't return a Boolean. It just does what it's going to do. All valid distinct word squares. I see. So here it actually looks like I can... reuse the same 4 words for a different square. So I think actually the way I would want to do this is to say something like for, is it permutations? For P and perms, yeah, I think I want that. Wait, is that what I want? Yeah. Fuck, how do you do this? Shit. Oh, you just do this. check. I think I could even have this just be A at I. A at J, a K at L. Perfect, okay. We should call them top, bottom, right, left. That makes more sense. So I must satisfy these. So if top at 0 doesn't equal left at 0, return. Top at 3 doesn't equal right at 0, return. If bottom at 0 doesn't equal left at 3, return. And if bottom at 3 doesn't equal right at 3, return. Or else res.append ABRL. Looks good, I guess. What happened here? Huh. So it's making these weird 2D lists, which is not right. Oh, it's because I say ABRL and A is predefined. Able also echo area. Able area echo also. Shit, what happened here? Oh, did I get the order wrong? Top, left, right, bottom. Able area echo also. Area able also echo. Good enough for me, but yeah, it looks good. Okay. Cost to make two binary strings equal. Flip cost, swap cost, cross cost. You're allowed to apply the following operations any number of times in any order to the strings S and T. Choose any index I and flip S. I don't know what that is. Not gonna pick that up. Apply the following operations any number of times. Turn an integer to know the minimum total cost need to make strings S and T equal. Okay. Any index I and flip S at I or T at I. Flip cost. How long can they be? 10 to the 5th, I'm guessing. Yeah. Swap either S at I and S and J or T at I and T at J. Choose an index I and swap S at I with T at I. Why would you ever do that? Swap S at I with T at I. What would be the reason for doing that? If you're trying to make them equal, you've just exchanged two. You would do that because it's kind of the equivalent of two of these operations. Okay. This you would only ever perform on one of them. This you would only ever perform on one of them. This you would perform on both of them. I think this you would only ever perform once. Because otherwise you would have been better off doing this and then possibly this. So if you went index by index, you could say, this is a 0, it's supposed to be a 1. Flip cost, swap cost, cross cost. I think you'd go forward. Wouldn't you just say, how many places do they actually differ? Like, what's the absolute value of the difference between zeros and ones for each of them? So here, I think the best you could do would be... Oh, no. The flip costs, they all have different costs. I see. Okay. Is there a Dijkstra's situation? How long is each string? 10 to the 5th. That's not going to work. Well, there's really only 3 things you can do. There's you flip this to be something else. There's you swap both of them, and then you swap this to something else, or there's you just swap this to something else. There's not that many people. Maybe I feel like cheaters have probably died down. So you're here, you kind of need some sort of greedy formulation that's just immediately figure out the right thing to do. So if you swapped these two, that would be pretty cool. You could say, just swap this 1 to some future place. And now you need a 0 and you have an extra 1. So anytime you come upon a 0, you're done. Or if you reached the end and you didn't have enough zeros, then you'd say, actually, I didn't want to swap this, I wanted to flip it. If you just had 0, 1, and 1, 0, as I suspect it'll kind of get reduced down to, I think you'd say, well, you could either pay flip times 2, or you could pay swap times 1. And cross is not going to help you at all. So it really would depend on if flip was more expensive than swap. Can they ever be free? Not really relevant, I guess. And no. I don't think DP will work. Because you'd say, what's the cheapest you can do from I on? But you would need, if you were swapping between indices, you need to represent that in the state. So that'd be O of n squared. So that's not really good enough. So I think it is going to come down to like relating the costs and finding a greedy formulation. So what can you do? You have some index here, 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 and here. If you swap and then flip, or what would that be? Swap and then cross. Then that gets you, this goes here. And this goes here. And then I think you would always do that right up until the final thing if the parity was off by 1. You'd need to do a flip. And you're only going to do that. How much would this cost otherwise? If you were saying these are the same and these are the same? No, these are not the same. This would be 1001. No. When would you ever do this? When would you ever swap and then cross? This has to be 1 and this has to be 0, or else you haven't changed anything. I guess you could have 1 and 0. So this would cost you swap plus cross or flip times 2 to just flip them to be the same. Okay. I don't think their actual indices really matter. I think the only thing that matters is the number of indices that are different. Yeah, and the total length. Number of 1s in S, the number of 1s in T. If OS and 1 doesn't equal OT and 1, that means you necessarily need to flip something from a 1 to a 0, or a 0 to a 1. So res plus equals flip. I mean, at the very least, there's no world where you would ever randomly flip something when you could have swap and crossed it, and then swap and cross something that you could have randomly flipped. So I think something you could do is you could just say res is equal to sum s at I doesn't equal t at I times flip. Just flip everything for I in range n. Okay. Damn. So this is saying if you just flipped everything that's wrong, you would get 50. That's fine. This one should do the same, except it happens to be right. This one should also get it right. Oops. So then it's a matter of that's the amount that's different. That's the ones in S. It's the ones in T. So you're necessarily going to maybe have one flip, and then, so I'll say, this is the, it doesn't really represent that much, but if OS doesn't equal OT, right? Could you do that? It's kind of a weird way to write it, but you're just saying flip a 1 to a 0 so that there's an even amount of them. And then you know every flip or every swap is going to add How do you the final question I kind of have is about the rearrangement, and then I need to kind of prove this all to myself in my head. I don't think I just want to say OS minus equals 1. And of course OS is not going to be equal to OT. I don't want that. I want to say OS plus OT is odd. Then do that. And then I think I'll just be really explicit. If OS is greater than OT, it goes down. So swap a 1 to a 0, or else OT gets swapped to a 0. This is to prevent negatives, but it doesn't really matter. Now I know that there's an even number of 1s between everything, which implies an even number of 0s. And then next up, I'm going to say how many indices are the same or different. And then for every index, let me run through this. So if we had like 1, 1, 1, 0, 0, 0, and you're trying to swap and cross, you'd say replace this with this, and then you'd get 0, 1, 1, 0, 1, 0. And then you need to flip one of them. I think I'm overcomplicating this severely, actually. I think I don't really give a shit about the number of 1s in S and T. All I care about is the number of places where they're different. So if there's an odd number of differences, such as this, then you do need your final thing to be a flip, which is fine. Everything that's the same, you completely ignore. It doesn't matter. And then it's a matter of MSF. think I'm going to call this res1. It doesn't make any sense to call it res. Or MSF. Res1 is equal to, plus equals, swap times cost, swap plus cost times x over 2. All right. That seems right. 18, 6, 0. Okay, what happened here? So what this should say is there's 4 places where they're different. No, because you could... No, you do need OS and OT. That actually matters. Because you could have something that's like 0, 1, 1, 0, 1, 1, 1, whatever. And then you'd say, well, I just wanted to swap. I didn't want to like... Yeah, I just wanted to swap. I think what I'll say is... A equals how do you do this? Yeah. So for every single place where there's a 1 and a 0, you can pay swap to get rid of them. And then everything else is going to be either flip or swap plus cross. Okay. A is that. So cur is going to be max 1 and 0 minus min 1 and 0. Is there ever any world where you don't use swap, but you do use flip and cross? No, I don't think so. Because why would you ever do that? Max of 1s and 0s minus min of 1s and 0s. So this would say you have 3 remaining. Do you need to do that? I don't even think you need to do that. You can just say whatever the minimum is, you can swap one of these. So I'll say min equals min 1 and 0. cur equals min times swap. Yeah. Man, this is all over the place. Okay, cur is minimum times swap. X is going to be equal to... X is the number you give a shit about now, which is going to be max of O and Z minus min. Now this is the amount you have left. You could try swapping and flipping only. We res is min, res, and cur plus x times f. Or you could try swap plus cross, and an extra f if you need to. If x and 1, cur plus equals f, x minus equals 1. Now the cost is going to be res is min res cur plus swap plus cross times x. And now that should be the correct cur. Fuck, it's even larger. So what happened here? It should say swap, swap and cross. So 2, 3, 4, 5, 6, 10. Why did it not do that? Right here I should see 12. Okay. Swap plus cross. Yeah. Res is min, res. Wait, what? X is 2. Swap plus cross is 4? Swap 0 and 1. Oh wait, cross swap. Oh no, yeah. Okay. So then you have 0, 0, 0 and 1, 1, 1. Oh, because I don't say x over 2. Whoops. That's the whole point of all that. Okay. 16, 6, 0. There's no time complexity issues. I guess I'll review it one more time. That's fine. So according to this, there's really 3 things you can do. You can just brute force. If flipping is the best thing to do, you do that. If flipping and swapping is the most effective thing, you try that. Or if swapping and crossing is the most effective thing, you try that. You can't get around flipping at least one thing sometimes. Yeah, that seems good enough, I guess. Nice. 2D integer array lists were listed as some non-empty array of integers sorted in non-decreasing order. You repeatedly choose 2 lists. And merge them. The cost to merge them is A plus B plus the absolute value of the median of A minus the median of B, where the length and median denote the list length and median respectively. This seems like a greedy thing immediately. After merging A and B, remove both A and B from lists and insert the new merged sorted list in any position. Repeat merges until any one list remains. Return an integer denoting the minimum total cost required to merge all lists into a single sorted list. So I feel like there may well be a way to do this greedily. If A and B, the median, blah, blah, blah. You need to quickly be able to recalculate the median. Probably. Well, maybe not. Because how many times are you really merging to... I don't even think you really need to do that. Oh, the sum of lists at I.length will never exceed 2,000. So yeah, I don't actually think you need to be able to recalculate it quickly. I think you need to say, if two things have the closest median, do you always take that? Or is there some reason to take another median? Well, if something has the lowest median and you combine it with something else with a higher median, that can only raise the median. Therefore, you would always want to combine the lowest median with the next lowest median. I don't know why you would ever not do that, which would imply that you just make a heap of all of them and then you just recalculate the median over and over again, which you're going to do 12 times, but that's fine. Why would it not be that? I feel like so confident in that I want to just start coding it out. If you have a given median, let's take the lowest median, and you combine it with if you could combine it with any other median, it will only cost more if other medians are combined first. I don't think it's exactly that simple. Because I feel like, well, maybe. If you had like A, B, C, if this median is 11, 10, and 1, okay, maybe you do need to figure out how to recalculate the medians quickly. There's a world where it's greedy and you don't, and you just plug them all in. Or there's a world where you need to find the exact ordering of combinations. Oh, it might be that. And then you can just pre-calculate. Maybe not. Because 2 to the 12 is like 4,000. The sum of this will never exceed 2,000. So each of these will never exceed a length of 2,000. So you could calculate every single distinct list. I think this is, my idea here was wrong. Because like my idea is then you would want to combine 1 and 10. But then what if these two gave you like 11 as your new median? And what was the cost is the difference in medians? Is that right? Plus the length. Yeah, so actually that completely throws that out the window. So if you could pre-calculate all median at mask, then if you had the medians for everything and also like the length at mask, seems like I might want to use C++. Then I think you could also pre-calculate all cost of mask 1, mask 2, right? You just need to be able to do this in O of 1. And then you're kind of golden. And then it would be, you could almost just do backtracking. Backtracking would be, you have a series of, you have a list of things. So you would have a list of masks. You would combine them. I don't think you would want to do backtracking. You might want to do DP or something. Yeah, you could do DP. You could say DP at mask is going to be equal to cost to obtain mask. And then that's going to have some transition. There's going to be a state space of like 1,000. I think you're kind of good there. And then you would return DP at 1 to the limit minus 1 or something like that. 1 to the k. 1 to the n. Minus 1. Okay. So this would be O of 2 to the n state space. That's fine. The transition should be, I guess, O of n. I don't know. Or O of, it could even be O of 2 to the n. So what would that be? That would be, you take every submask, you check the inverse. So you could get this to O of 3 to the n instead of O of 4 to the n if you were smart about it. But I don't even think you need to do that. But let's just say O of 2 to the n. Transition. But this all is predicated on the only missing piece, that is the fact that you need to be able to, you can pre-calculate all this, but you need to be able to pre-calculate the cost of this. How's it going? Pretty well. I think Q4 is, I mean, I might be speaking too soon, but a lot easier than Q3 for me. I think these, I'm like a lot better suited to these. Contest 483. Let's go back to the Tyler head dent. Okay. So calculate the median of a mask. There's 2 to the n masks, right? Times the median is going to be m, I'll say. So 2 to the n is roughly 4,000. I think I'm just going to try coding this out in Python. I think it's going to be so much faster than C++ if I don't have my like macros and stuff, that it's worth the 5-minute penalty if I get a TLE. If I get a TLE though, then probably got to swap to C++. Okay, it's O of 2 to the n times m. 19 on the virtual, nice. For the median and the length, right? Yeah. And then f of this, it just uses the median and length. So it's pretty basic. You don't even really need to pre-calculate this. I feel like you just reference this table, right? Is it worth pre-calculating it? Maybe for like contiguous memory access, but I don't think that matters. This is O of 1. So this, I immediately am like, okay, this looks fine. N is length A. Let's see, what do I want to do? Do I want to just do this in C++? I think I'm just going to do this in C++. No, I'm not going to do this in C++. I get so intimidated by the not Visual Studio Code C++ IDE. Lim is equal to 2 to the n. Looks good. And now I want to find the median for every single mask. So median is going to be equal to, I don't know, 0 times lim. Looks good. I'll say length. Is it specific to this contest, or will they increase the time limit from now on? Is the time limit increased for this? Length is also going to be equal to 0 times lim. So first things first, I should just get the... Yes, look top right. Oh, like the... Oh, interesting. I thought you meant the runtime limit. Is there a smart way to do this? Yeah, there is. Because if I have a given mask, like I need to assimilate everything and then sort it. And in Python, that's pretty dicey. So I'd rather keep them sorted. So I think what I would honestly rather do is just say masks equals blank for blank in range lim. And then say for I in range n, masks at, what's this going to be? So, what was the plan here? It's going to be masks at 1 is going to be A at 0. So it should just be masks at 1 to the I is equal to A at I, right? And then for I in range, oh no, are you going to have to like assimilate? Is it going to be like a median of M? Wait, no, I'll just copy paste my code from that other Leetcode problem. I don't care. So it's going to be merge K sorted lists. Do I even need, I feel like that's not that difficult. Like to just do if I've already done it. For, okay, for mask in range, lim, if masks at mask, if it has anything, then that means I already did it and I don't want to go back. Okay. Now that it doesn't have anything, I know that I need to assimilate this mask. So what I need to say is this, and then I need to assimilate it from... No. It's not going to be that bad. I only need to ever merge 2 sorted lists. Because what I can do is I can say whatever... So, okay, if you have some mask, this, let's say, you're like, okay, I need A, C, D, E, G, H, I, J. I need these sorted lists assimilated into mask. But the thing is, you already have this mask, right? So what you really need is just this assimilated with that. So there's always going to be 2, and that's why it's better to pre-calculate it this way. I think they generate their statement with an LLM. Maybe. I've started to assume they specifically, the name of the game is just to confuse people who are trying to solve it with an LLM. Okay. So here I'll say A is equal to, let's see, how's this going to work? So for a given mask, you will always have a greatest bit. I forget how to find that in Python. All right, we'll still figure it out. Oh, bit length. Okay. That's so much nicer than built-in CLZ. I guess I don't really want to use A. I'll use X and Y. Zero, zero. Is that right? I guess I should start with 3, right? That's the first one I'll actually care about. 2, 3, 3, 3. I'm guessing if I used 8, it would go up to 4. Shit, whatever. So I guess it would be this -1, right? This is now going to be 1 to the blank. So this is like 2 squared, 2 squared, 2 to the 1. Are there any larger lists? No. But whatever. I can just make a larger list to make sure. Yeah, okay, good. But it skipped 8. No, I want it to skip 8 because 8 is already set. So I'll say x equals, well, I'll say bit equals mask.bit length -1, but it's 1 to the this. X is equal to masks at mask XOR bit length. Y is masks at bit length. Okay. So then it's just going to be a simple I equals 0 for j in range length y, while I is less than length x. And x at I is less than or equal to y at j, I guess. Masks at mask. I'm just going to say cur. Dot append x at I while I is less than length of x, cur dot append x at I. Okay, that should create every mask. Why don't I say print cur just to make sure. What happened here? I think I want that. Y at J. Yeah, these look good. Okay, and then I can say med mask equals mask at is the middle element after sorting it. If the array has an even number of elements, the element is the left middle element. So if you have 3, it would be 1. If you have 4, it would be 1 still. Right, so it's going to be this length of mask. Median at mask is going to be mask at length of mask minus 1 over 2. Okay, length 5, median 3, length 6, median 5. Yeah, looks good. Okay, length and median is made. Let's see, should I make a custom f function? No, probably not. What was my plan here? So I can just calculate f on the fly, that's fine. dp is going to be times lim. So it's going to be very similar for mask in range. Let me just bring this up here, I guess. Okay, it costs to get this mask. dp at 1 to the I is equal to 0. Yeah. I guess I could just calculate it here. There's no real reason not to. No, I'd rather do this on its own thing. Let me get these. Okay, building median and length through everything. That should be fine. Build dp. So we got that. If not x. I don't really need masks anymore. I can just say mask XOR bit. And I guess bit. No, there's no, it doesn't really matter anymore. I'll say if not mask XOR bit. It's already a power of 2. It's already been handled. So continue. Or else x equals mask and mask minus 1 while x does not equal 0. Y equals mask XOR x. Now we have the complementary. So you combine both of them and you get this. So cost is going to be length of x plus length of y plus the absolute value of median at x minus median at y. dp at mask is equal to the min of dp at mask and dp at x plus dp at y plus cost. We'll we'll speed up. X equals X and X equals mask and X minus 1. That seems right. 8. Shit. Let's see what we got. So 0 costs nothing. Everything else costs nothing, which is not right. This should go through. Right? There are costs to things. Why would there ever not be costs to things? Does length is full of something, right? 0, 0, 0, 5. Oh, I never set the length for these. So length at mask is equal to length of cur. Median at mask is equal to this thing. And then continue. Yeah, that seems good. 12, getting closer. So it's saying, oh, and I actually do want to start with 1 now. Whatever, I'll just do everything here. 18, so I said, length is 3, 2, 5 if you combined both of those, 3. If it works for all the test cases, I'm just going to go for it. 18, 10, 4, 2. 18, 10, 4, 2. Come on. Don't be slow. Nice. Wow. That was a long run time. 79. Okay. That would probably up my rating. I guess Leetcode contests, they've chilled out with the LLMs. Wow. Isn't this like way worse than it used to be? $79 for me, but most are AI nowadays. Yeah, I guess I don't really believe that Cranky Bag that Cranky Bag is a legitimate contestant. I mean, maybe, but they started in March and it looks like they participated in a... Yeah, I don't know about this. That's a shame. Damn. I guess this is why I don't do these anymore. Yuck. Jesus. Do they link their actual Chinese coders? Are any of these people real? Maybe. No, I don't think so. No, maybe. I mean, because look at this. They're getting like, which one's which? Let me go to a non-Chinese one. No, this works. So they're, wait, no. Does this work? Yeah. This is clearly fake, but. Okay, so it's the right number is the what place you got. The left number is what your elo is after. So for this guy, yeah, this guy seems like he's probably legit. Because he's getting top 20 consistently. And then he just stopped. Like, he could, every single contest he's doing better and better, up until, I guess, he's doing what I have done, where the moment you do slightly poorly... Wow, what the fuck? That tanked his score. What happened there? Then he stopped for like 6 months, and then he kept going. And for these, yeah, this actually checks out quite a bit. So he's getting like top 20 in 2019. We know there's no LLM use, so that's fine. And then he's getting like not even top 20. He's getting like top 100 on average. So there are people who are like up here. It's not just bots. This is a real person. I believe this. Very consistent. Wow. So how's their score been since LLMs have come in? Let's see. Around 2024 was when LLMs began to be like a problem, I want to say. Right, this is when O1 came out, and this is when people really started cheating. So their score actually went up by like 300 elo, and since then it's gone down by 400 elo. Why mostly they're Chinese on top. I feel like their schools are just better funded than ours. Or I don't know, than American schools. I don't know where you're from. Wasn't there a mode where you could like, they had like a video where it was like, this is exactly what they were typing. Okay, wait, they imported a heap and binary search and segment tree. And a Fenwick tree and DSU. I can't imagine they're using that. Yeah, they're just doing the same thing that I did. It's kind of a fun problem, I guess. It's kind of cool when they stack up. What was my time? An hour. Wait, for real? Oh, that was 2.5 hours. That wasn't even too... Right. Yeah, I mean, I guess they do. It's just weird. It's just weird. They don't have any of the, like, input-output stuff. I guess binary search and segment tree people are using a lot. It's just weird. Like, if this is an LLM user, that's odd behavior for an LLM user to, like, import a bunch of random crap. But maybe that's, like... Yeah, if they completed it in 16 minutes... I feel like they probably had to like mess around with the LLM. They had to be like, no, that doesn't work. Do this. Actually, yeah, that checks out. Because my first thought was like, this seems like you could almost use a heap. Why couldn't you? And I drew for like 1 minute and I was like, okay, you clearly can't do that up here. Wherever it is. Yeah, right here I was like, okay, you can't use a heap. You could do 2 to the n. This person probably spent about as much time, but they just told the LLM like, okay, wait, no, use a heap. And then it was like, okay. And then it was like, actually, no, wait, you can't. And then they were like, fuck, what do I do? One times 104.25. 2 wrong answers on Q3. I don't know how the fuck I figured out Q3. I've been doing enough Codeforces that, like, you just gotta prove it to yourself. I don't know. It's tough. It's weird they show me as 19th in the contest tab. I think they don't... What I've noticed is the ranking is, like, too immersive. Where if right now I had, like, 4 wrong answers, this would be updating to be lower and lower. Because it's, like, simulating the tension of after you finished, like, in a real contest. So I think it's... I know exactly how they're doing this orbiting effect. I've done this before. That would be my guess. Is like if you waited the full hour, or like after the 15 minutes or 10 minutes for your 2 wrong answers. Oh, I don't know. It might be only American versus Chinese. Or I guess not only only Western versus Chinese. That's really imperialist of me. Happy New Year, Opto-Elliptical. It's going to be a good one. Hopefully. We're off to a really disastrous start here in the Americas, but whatever. Look at how many Chinese people are in the rankings. Yeah, I don't think I've found a single one that's not. Yeah, wow. I wonder why. I know for like Indian people with Codeforces, like I think a lot of Indian colleges require people to do Codeforces. And then like your like curve is based on your Codeforces ranking, which is really interesting. I imagine that's where most of the cheating comes from because that's a huge incentive to cheat. Hulk 69. Oh, that's a shame. Look at how many Chinese people are in the rankings. This is me. Your Q4. Let's see. Oh. Yeah. This is pretty much the same, I think. Right? Wait, what? No, I don't think this is the same. So what are you doing? No, I think this is. You're just not pre-processing, right? Yeah. And I'm assuming you're like predefining. Yeah. L2 minus 1. I think this is the same, just much more succinct code. This one was kind of cool. I don't think anyone was watching my stream while I did this, but I was like, I'm kind of surprised that I just kind of hacked it. I kind of just figured it out. If S1, blah, blah, blah. Min cross plus swap, blah, blah, blah. I'm curious how many terms you had. You also had 3 terms. So yeah, you did the same thing, but again, your code is much less verbose. M at BM represents the merged sort list of all lists represented by the indices in BM. Wait, yeah, did you not merge them? How did you do that? Wait, you just sorted them. Did I see that right? Yeah, you just sorted it. Wow, I'm kind of surprised that passed. Isn't that like 4,000, right? Or like, what is it, 4,092? 1024 times 4, yeah. 4,092 times O of 2,000, although it's not going to be that. Let's say like 1,000 times, it's n log n. So that's going to be like log of this is going to be roughly 10. Wow, interesting. Yeah, I guess. I mean, 10 to 4e7. I guess that's good enough. Sort is fast in Python in practice. From my experience, it's faster to do sorted L1 plus L2 rather than the 2 pointers method. That's good to know. Have you done any contests recently? Oh, wow. You have. Wow, good job. Jesus. You are going to pass me pretty soon, which is impressive because you're fighting against AI. Okay. I'm going to try to do one more contest. Yeah, I'm going to try to do one more. I'm going to lose Elo on the bi-weekly. 700th. That stings. It's not that bad. I don't know. Reverse string prefix. Reverse the first k characters of S. Is k less than or equal to n? Yes. Return... I don't even need to do that. Return S. Let's see. It's going to be down to -1 from k minus 1, right? Yeah. Plus S from k on. BACD ZYX. Uh-oh. What happened here? K minus 1. -1, -1. Does this not do anything? What is this doing? From my understanding, from k minus 1. Am I crazy? -1, -1, -1. Oh my god. My Python rustiness is showing. Alright, well then fine. Then up to k, backwards, and then k on, right? Hey, ZYX, BACD. I don't know what went wrong there. I'm going to go back with that one. Hopefully 500th after disqualifications. You're given an integer array nums and an integer k. Return the minimum length of a subarray whose sum of the distinct values present in that subarray is at least k. So it's monotonic, so you could binary search, right? No such subarray exists. Return -1. So in the world where no such subarray exists, so it's going to be the sum of a counter. I do have to do this in like n log n. Do I want to try and venture like a bisect left, or do I just want to do L and R 2 pointers? The minimum length of a subarray. I don't know. I think this should be okay. What happened here? Okay. So C equals counter. We'll go from there. The numbers can't be that big. So I could just do C is equal to like, nah, whatever. This is fine. C is counter, L is equal to, wait, what's the plan here? No, I don't even think I need to, wait, what am I doing? Minimum length of a subarray whose sum of the distinct values present in that subarray is at least k. I think I'm like thinking too weakly. I think I can actually just say, just do 2 pointers and I can have it be linear, right? The minimum length of a subarray. So you keep growing up until it's above k, and then you increment L. Yeah, that should be fine. So while I also need like a cur, right? While cur is greater than or equal to k and L is, I don't know, less than n. I don't even think I need that, but whatever. right? Because if it winds up being equal to r, L is the next thing on the chopping block. So if it's equal to r plus 1, then you have nothing. So then K would have to be 0, which it can't be. So, but this is fine anyway. C at A at L minus equals 1 if C at A at L equals 0, then you've removed this distinct value. So cur minus equals A at L. C at A at R plus equals 1. If C at A at R is equal to 1, then you've added that in. So cur plus equals that. And then I also need to say right here, you found a valid length that works. So let's say K was like 5 and you had 2, 2, 3. You'd say this does work. R is at 2. L is at 0. So you'd want to say R plus 1 minus L for sure works. Three, 3, 2. Okay, well maybe I'm off by 1. Zero and 1 works. Wait, did I? Wait, what? Oh, no, here. Okay, it said 0 and 3. 0, 1, 2, 3. Does it not work? Do I need to binary search? That doesn't sound right, because as you include more things, you can only increase your sum, and as you remove more things, you can only decrease it. So that's for sure non-decreasing. That's monotonic for sure. So why is this 0 to 3? K is 4. So it should see here 0, 1, 2. Oh, it's because I'm removing instead of adding. That's the problem. So it's off by 1 for that reason. 0, 1, 2. 2, 2, 2. Shit. It should just immediately see that that works. Yeah, okay, that was the problem. Shit. Oh. Damn, classic Leetcode error. That feels bad. Find maximum value in a constraint sequence. You're given an integer n, 2D integer array restrictions, and an integer array diff of length n minus 1. Your task is to construct a sequence of length n denoted by a0, a1, an minus 1, such that it satisfies the following conditions. So we need to construct A. A at 0 is 0. All elements in the sequence are non-negative. For every index, the difference between two indices is less than or equal to difference at I. Okay. For each restrictions at I, the value at position index in the sequence must not exceed max value. Okay, that's not that bad, right? You just kind of count up. Wait, what if it's not possible? Right? No, it could. I guess it could always be possible. If difference at I can't go below 1, you could always just have everything be 0. So it's going to be one of these annoying linear relationship things. where I think you have to build the implication graph forward and backwards, where you say, if this can't go above 5, that means this can't go above, like, or if 8 can't go above 1, then that means, like, this can't go above something else, and so on. Yeah, that's not that bad. Can restrictions be empty? No. It has to have at least one thing. That means, in theory, everything will be not negative. Right? Maximizes the largest value within this sequence while satisfying all of the above conditions. So you'd say go forward. So this is saying at index 3, you need a 1. So go forward from there. Yeah, I feel like once I get this set up, it won't be that bad. Can restrictions at 0 be anything? No. For I in range from 1 to n, abs I minus abs at I plus 1 is less than or equal to difference plus I. I think what I'm going to do is say b dot append 0 and 0, b dot sort. Can there be multiple? The values, no. If idx is less than length of b and b at idx is 0 equals I, then value is equal to min value and b at idx at 1. Okay, that looks good. And then something, and then x plus equals d at I think. And then this is just going to be a at I equals x. Right? So this is everything forward. So it's saying 0, you can go up by 2 to get to 2. You can go up by 2 to get to 4. You can go up by 3 to get to 7, but then this has to be a 1. You can go up by 1 to get to 2, 4 to get to 6. That seems right. And then I just need to do the same thing backwards. So idx is length of b minus 1 for I in range. Minus 1, minus 1, minus 1. That I know is correct. Wait, I just needed to leave the field blank for question 1. I think that's how slicing works in Python. For I in range n minus 1, minus 1, minus 1, if idx is greater than or equal to 0 and b at idx is 0 is equal to I, x is min xb, idx at 1, idx minus equals 1, a at I equals x. If I is greater than 0, x plus equals d at I minus 1. I think that's how that should work. So it'll say currently if you're at the end, it's going to go up by 2. But then this will be a at I equals min a at I and x. And then I just need to say x equals infinity. That seems right. 0, 2, 4, 1, 2, 6, 3, 2, 1, 3. Zero, 2, 4, 1, 2, 6, okay. And then I guess I'm returning max of this. 6, 12. I don't know, looks good. Nice. Count routes to climb a rectangular grid. You're given a string array grid of size n where each string grid at I has length m. The character grid at I at j is one of the following symbols. Cells available or the cells blocked. You want to count the number of different routes to climb grid. Each route must start from any cell on the bottom row and end in the top row. However, there are some constraints. You can only move from one available cell to another available cell. Makes sense. The Euclidean distance of each move is at most d, where d is an integer parameter given to you. The Euclidean distance between two cells R1 and C1, R2 and C2 is the square root of that. Okay. Each move either, what am I doing? Different routes to climb grid. The Euclidean distance of each move is at most d, which I'm guessing is an integer. Okay. Wait, 750? No, 750 times 750 is still pretty big. I feel like you could be smart about that. I feel like you could, I don't know. You know that the Euclidean distance is always going to be spherical. So you're going to have like, well, each move either stays on the same row, or the row of directly above. Wait, what? How is this? You cannot stay on the same row for 2 consecutive turns. If you stay on the same row in a move, and this move is not the last move, your next move must go to a row above. Okay. This seems not that bad. So you'd say dp at the top is 1. There's one way to just stay there. I think, unless they're saying you can travel between the top, but I don't think that really matters. However, we cannot move from cell 1, 1 to cell 0, 0 because the Euclidean distance is the square root of 2, which is greater than d. Wait, this is saying you can't, so you could say go from 1 to 2 or 1 to 2 to 3. So you can travel between the top row. That's kind of annoying, but it doesn't, I mean, whatever. Okay. So it's going to be something like dp at I at j at k, where k is the number of moves you've had within the row. And then it's not going to be that bad because you're just looking at the previous row. You can't really do 750 cubed, but you don't really need to because you just have a prefix sum and then you're fine. You just find the furthest point away that you can travel to, and you take everything in that prefix sum. So if it's the row above, it's going to be the square root of it plus 1, of it squared plus 1. That's like kind of annoying. If it's the same row, if you're saying I want to have traveled from the same row, then this is gone and you just have the square root of the difference squared, which is just the absolute difference. So then it would just be a really simple, you would just get the indices. For this one, I think you would just say subtract this At most D. So you want to find the index. You would just, I feel like you would just do a sliding window. It really wouldn't be that bad. You would just say the moment the difference is too large, you would move. Okay, that's not that bad. So I'll say dp is equal to that. I would prefer to have dp be contiguous by k, right? 0 times m for I in range n for blank in range 2. Okay. For I in range m, if, well, it's all 0. No, this is fine. I'll set the initial thing. So if a at 0 at I is equal to that, at 0 at I, so you can always start out at the top, and then there's one way to do all of those. Okay. For I in range m, and then I'm going to say dp at 0 is equal to accumulate dp at 0, and then I need to say how many ways are there to travel within this, which is a little bit annoying, but I don't think it's that bad. I think the constraints are so lax that it's worth just kind of separating out the functions. So I'll just say this. Is going to have the row. I think that's all I really want, actually. I don't really want to say like the number of ways to jump above for this given column in the row, because I'm gonna use 2 pointers, and it's gonna be a lot easier if I just do the whole row at once. So here, I think now I just want to say same 0, which is going to say now try jumping within the same row at the end, because it looks like we can do that, which is kind of annoying. Let's see. 4. Yeah. So this is saying you could start here and jump here. You could start... Wait. Yeah, you could start here and jump here. Or you could start and jump just at the same time. Wait. Yeah. Okay, yeah. No, that's fine. Okay, time to do same. And then for I in range something, something, something. N is what it is. It's going to be above I, same I. And that's really 1 to n. And then it's just going to be return dp at 0 at... Is that right? Yeah, 0 at n minus 1 at m minus 1 plus dp at 1 at n minus 1 at m minus 1 % mod. Same above. Now I just need to do these. Int L is equal to... So I think the way I want to do this is R is exclusive, L is inclusive. No, I want the exact opposite. I want L is inclusive, R is exclusive. Right? Let me think about this. So if you have your current row, there's the row above you, and you have some sort of radius that you care about. Boob. Then you're going to have some L and some R, and it's going to be at prefix at R minus prefix at L. Right? And then you're going to get everything up to there minus everything up to there. So I want R to be, but I think I am going to have it be exclusive, which is a little bit confusing, but it's going to be R is going to go forward until it can't anymore. And then it's really going to be prefix at R minus 1. And then L is going to go forward until it is within bounds. And then that's going to be prefix at L minus 1 is what's being taken out. So it's like off by 1, but then it's offset. And then I need to double check, like, okay, well, if L is at 0, like if the whole radius is like that, and it's well within bounds, then L would be here, and then prefix at L minus 1 is just going to be 0. I'm just going to say if L is 0, then prefix at L minus 1 is 0. If R is N, then there's no problem, right? Then prefix at R minus 1 still works. Is there any out of bounds stuff for prefix at R minus 1? No, because I'm going to say like while R is less than or equal to N or something like that, or while it's less than N. L and R is equal to 0 and 0. I could pre-calculate that if I really wanted to. Do I care about that? No, I don't really care. For J in range N. Okay, first things first, while R is less than N and I'll just say distance. Oh, this is same. I'm going to do different above first because I'm already kind of working on that logic. While R is less than N and distance from J to R is less than or equal to D. This is while you're within bounds. I don't think there's any world where you're ever outside of bounds this way. You could never have R be back here because R starts here. This starts here. If D was exactly, I can't imagine D is supposed to be below 1. So if D is 1, that would mean that R is going to always increment by 1. It's always going to be the next invalid thing. You're always going to get just this. And then L is always going to increment to be this, and then you would have this single element, and that would be fine. And distance from J to R is less than or equal to D. R plus equals 1, while L is less than N, I guess. And distance from J to L is less than or equal to, is greater than or equal to D. Is it equal to? What am I doing? Where does it say? The Euclidean distance of each move is at most D, where D is an integer parameter at most. So less than or equal to and greater than. Is that right? Distance from J to L is greater than D. That means it's invalid. You want to increment until it's valid. So L plus equals 1. Okay, now you have R and L. And I think I'm just going to say rho equals dp at 0 at I, and prefix is equal to dp at well, let's see, it depends on how I want to define this. If I'm saying above, I'm saying you're about to jump to above. I think there's going to be a little bit of confusing logic here, where if you have row I plus 1 just got here, and already jumped within row I. So already jumped within row I is going to draw from here, and that's the only thing. Row I plus 1 is going to draw from both of these. It's going to say you could have just gotten here, or you could have already jumped. I don't really care. And then this is just that again. So that means if I'm calling above, I need this prefix and this prefix, and they should have already been calculated. So prefix 1 is going to be dp at 0 at I minus 1. Prefix at 2 is dp at 1 at I minus 1. Okay. And then row at j is equal to prefix 1 at R. Well, I kind of want to say L val is equal to prefix 1 at L minus 1 plus prefix 2 at L minus 1 if L is greater than 0, else 0. R val is equal to prefix 1 at R minus 1 plus prefix 2 at R minus 1. And there's no problems there. Right? R will always increase. Yeah. R will always be greater than J, or else there's a problem. Val is equal to L val, R val minus L val. Whatever. I'm just going to say dp row at J is equal to R val minus L val percent mod. I don't think I have to worry about using too many percents. Okay, that should handle above. And now same is going to be very similar. I need to find dist too. So it's going to be square root of I minus j squared plus 1, because I'll always be comparing a distance of 1, a vertical distance of 1. I could cache that. No, I don't care about that. Okay, same is going to be very similar. So L, R is 0, 0. Row equals dp at 1 at I. Now you're saying I want to jump within the same row. Prefix is dp at 0 at I. For j in range n, while r is less than n, and r minus, I mean, this is so simple. I don't really need a while loop here, right? I could just say r equals min n and j plus distance minus 1. So if you had 1, 2, 3, 4, 5, 6, 7, 8, 9, distance is equal to 4. Let's say you're at j equals 4. You'd be able to say, okay, it's within a distance of 1, 2, 3, 4, 5, 6, 7, 8. Wait, wouldn't it just be plus d? I don't think there's any minus 1. N minus 1 and d. And then minus that, so down to 0. Yeah, I think it's much simpler. 0, j minus d, Okay. And then it's going to be not exactly the same as that. I'll write it out by hand. So lval is going to be prefix at L minus 1 if L is greater than 0, else 0, rval is prefix at R minus 1. Row at J is equal to rval minus lval percent mod. And with that, it should be good. I don't know. Oh. dp at 0 at I. What was I trying to do here? I'm saying go through the 0th row, having not jumped. Can you do that? Yeah, that's fine. It's equal to A at 0 at I equals that. Oh. Three. Okay. Not a great start. 6. So it's over counting. Let me start with this one. 2. Print dp at, let's just say 0 at 0. This should be, if you started at the top row, it should be 2 1s. True and 2. So where on earth did that 2 come from? Oh, no, okay, yeah. It came from that because it's a prefix sum, right? So it's saying there's one way up to here, and then there's 2 ways up to here. So that's fine. Okay. And then the only other really thing that matters is dp at 1 at 0, which should be... Yeah, there's 2 ways for each of them, right? 2 comma 0. So it didn't set this for some reason, which tells me there's probably an issue. Yeah, I think right here for j in range n, it should be for j in range m because I have them backwards. I think that's the only place I use that. Here I use m, here I use m and n correctly. That's the only place I use m here. It's the only place I use it here for I in range 1n. That's correct, okay. 4, 0, 6, 3. So what happened up here? Here I'm saying there's 2 ways to have done this. That's true. dp at 1 at 0 is saying how many ways are there to have jumped in between them. This is saying there's 1 way because you could have jumped from here to here or here to here. So that's true. Okay, and then the thing that really matters though is this. It should say you can't have jumped from here to here, and you can't have jumped from here to itself. I think probably it's the blockers. I think I'm not accounting for the blockers properly. So I think what I want to say is if A at I at J is equal to that, continue. And then same for up here. Print dp at 0 at 1. I wonder why a continue would do that. A continue doesn't do that, it just does that anyway. Wait, what was the last thing I did that made it do that? Oh, I changed, I see. 360. Oh, I haven't commented these. 1, 3, 0, 4. So the 4 is still fine. This says 1, which it shouldn't. If n is greater than 1, do that. So this is saying there's no way to jump within the first row, which is true. That's fine. And it's saying there's only one way to jump to the above row, which is wrong. So then if we look at the above row, it's saying there's one way to just be here and jump to something above, which is you complete the game. And there's one way. No, it's saying there's 0 ways. Actually, that's interesting. So that's the problem. Right here it should say 1, 2, but it doesn't. So that means in same right here there's an issue. Let's see. Well, D is 1. So this is going to say L is max 0 and J minus D. So this should be 0 and this is 1. R is min n minus 1. I didn't fuck up my lambdas. J plus D. So they're both inclusive, right? You're saying you can jump exactly this distance. So you can jump exactly up to L and R. Oh, I think I forgot to do a prefix sum on everything. That's the thing. This isn't that it's being Havortism. I know. It's not that it's correctly calculating this, but I forgot to say something like dp at 1 at I is equal to that. And then I want that down here too. Shit. Except this is going to blow up and be big. So what I want to say is like, I think I can just do the lambda here. Lambda x and y, x plus y percent mod, right? I think it's like that. And then same there. There we go. Okay. Q2 for this contest is not a medium. All right, 2, 4, 0, 6. Fuck, 6, are you kidding me? What happened here? So it's saying there's 2 ways. It's because it's including itself. It's saying, what if you jumped to yourself, but you can't jump to yourself? So here I need to say R val minus L val minus yourself as well. So I'm not the right one. That's going to be up here. R val minus it's going to be a little bit confusing, but I just want that non-prefixed dp at 0 at I. So R val minus it's going to be actually pretty dumb. I think there's a really easy way to get an out of bounds error, where if you're saying I'm at I equals 0, and I'm going to have some R val up here I care about, and some L val down here I care about. And just like the L val, really I'm saying take out before this, which is nothing. There's going to be the same thing where I'm going to say add this in and take this out, which is going to get this actual value right here at the 0th element, or like at the ith element. So I want to do the same thing. I think I kind of want to say like I val equals pref at I val minus equals pref at I minus 1 if I is greater than 0, or else 0. And then I can say minus I val minus L val. U2 vortism. Yeah, I forgot what Q2 was. Minimum. Oh, yeah, this one. Yeah, there was a lot going on there. Okay, 4, 0, 0, 0. Fuck. I really shouldn't have messed that much up. Pref at I minus 1 if I is greater than 0, else 0. I did it in same. Minus I val minus L val. That shouldn't really change that much, right? DP at, yeah, wait, what? DP at 0 at 0, DP at 1 at 0. So this is now saying there's no way to jump between them, but there's exactly one way to jump between them. So this should still be 1, 2. Q2 of the weekly. One, 1, 0. What am I doing? Wait, this is the wrong spot. I don't care about this. I care about this. Oh yeah, word squares 2 was weird. This was just like, do you see that if you brute forced it, it would be fine? Which was kind of an odd, I think the permutations thing too, if you're not using Python, that's like really annoying. Zero, 0, 1, ILR. So it's saying you can jump, but the distance is 1. So I think what's going on here is that right here R is inclusive and I'm treating it as exclusive. I think that's the issue here. And it happened to be counteracted before. So J, fine, J plus D plus 1. And then min N. Okay, 2, 4, 0, 2, 4. Fuck. Oh my god. God, that's annoying. Okay. M. It's supposed to be M, not N. Ooh, that would have been bad. That would have been really annoying. Okay. 2, 4, 0, 4. I think that's kind of good. I'm pretty certain that this will work. It's just a matter of did I fuck up the implementation? And I feel like these kind of cover enough implementation corner cases. Simple Q2 of the weekly. Okay. Whatever. Okay. What's going on here? Mine should say, I think it's probably going to be this fucked it up. So I said there's one way to jump, which there's not. And there's one way to not have jumped. So why did it assume that there was one way to jump? It should have said the only thing you can jump to is this. That doesn't work. So why did it not do that? For same, let's see. I and J, L val, I val, R val. I should see that R val is 1. It's saying everything up to here, you can jump 1 of something in there. This itself takes up 1 though. And then L val is 0. But it said I val equals 0. Oh. Oh my god. Yeah, it's because I'm saying pref at I, not pref at J. Okay. Well, that's what I get for using I to be the horizontal indices here, and then I to be the vertical indices here. Damn, what a stupid error. Do I do that anywhere else? That's fine. Dist at J, that's fine. Okay, now it gives 1. DP at 0 at I, that's fine. Row at J. Changing that to J val. J greater than 0. DP, okay. I think I'm overthinking it now, even though I just got a wrong answer. It should be good. 2, 4, 0, 4, 1. Damn it. What happened here? Pref 1 at R minus 1 plus pref 2 at R minus 1. It should never be doing above here. The fact that it's doing above there is very weird. Right? Why would it be doing above here? Because I'm saying for I in range from 1 to n, so skip the 0th row. Grid is, oh, I see. So there's a single dot and then a single other dot. So I wonder if this has to do with me fucking up the ends again. Let's see. I bet it's, yup, right there. R is Y, Y on Earth. Okay, I'm going to do a comb through. Let's see. So N and M. N is the height, M is the width. 0 times M for I in range N. So get a big rectangle for K in range 2. That's, did you jump in the same or go different? For I in range M, and I'm going to change this to J for my own sanity. I'm saying set at the end if you jumped from here. If you jumped from the top, then that counts as 1. That's like the beginning. Okay, accumulate, same at I, so L and R. Row is this, prefix is this. For J in range M, that, min M, J, that's fine, J, J, that's fine. J val, that's fine. DP at 1 at I is that, that's fine. Okay, it should be good, although I just said that 3 times in a row, but it should be good. Don't you think they're lacking originality in the last contests on Leetcode? I keep seeing digit DP, bitmask DP, grid DP. I swear that's the only... I swear there's only that these days. I mean, from the 2 I've done, yeah, I guess I see that. Like, this wasn't... I don't know. I guess the name of the game has changed for them because they have such a problem with cheaters. Like, I don't know why they would care about anything other than mitigating cheating. All right, whatever. I'm in so deep. I'm just gonna keep doing it. What's the actual answer for this supposed to be? I'm saying 1. The only thing you can do is jump from here to here, and then you're good. Okay, that's for sure a negatives problem. Man. Good thing I didn't actually do this, because Jesus. So it should say you can jump from here to here, and here to here. In each of those, you could either go straight up or jump to here. So there should be 4 things you can do. So it's saying as far as just going straight up, yeah, in total there's 3 things. Here there's 1 thing. As far as jumping side to side, this can jump to 1 thing, this can jump to 2 things, and this can jump to 1 thing. So that's right. Okay. As far as going side to side, none of them can do anything. That's right. This, if you jump up, there's 2 options. This, if you jump up, it's saying I think it's saying there's -3 options because it went down to a negative and then wrapped around. So in what world, right here, this would be I equals 1, j equals 2. So what is it giving for these? And what's the actual L and R values? I would expect the L and R values to be... It can jump up to at most this and at least this. So both of them should be 2. I swear to God if it's another I and J thing mixed up. No, I guess this is right. Because it's saying... no, it's not right. These should exactly be swapped. It should say... It can jump up to... Past here is the first thing that's not valid, and this is the first thing that's valid. So the fact that it's 2, 1 is not right. There it is. There it is. L is less than N. Oh my God. Okay, well, it didn't fix it, so at least there's something else. God damn. That's just sloppy. It's still saying 2, 1. 5, 2, these are not relevant. No, that's the R val and L val. That is relevant. 2, 1. So it's saying the first thing that is valid is this, and the first thing that's not valid is this. So you're going to get a weird negative number that doesn't make any sense. -3, which makes sense. Well, L's less than M. And distance from J to L is greater than D. What happens if J is just equal to 2? This is only called there. So what happens if we get rid of this and I just say, like, for every single J, what's the L and R? So in J equals 0, it says you can jump up to here, and then it's not anything past here. So that's correct. For J equals 1, it's not relevant. I see. This only works if I still need to increment these. Okay. All right. That's fair. That's an honest to God oversight. I mean, they all are, but... All right, let's let her rip one more time. Good Lord. That was rough. The first contest went over well. Oh, wait, that's the wrong one. Whew. Not the worst. Not that bad. I think this would probably... It wouldn't tank my score that. Like, yeah, it wouldn't be that bad. Good boy. Okay, we'll go out in half an hour, okay? Good boy. We'll go out in half an hour. Does that sound good? Good boy. We'll go out soon, okay? Alright, I'm gonna take my dog out in a little bit. I'm giving myself until 4:30. Does this? Yeah, it looks at this. Maximum value in a constraint sequence. Which one was this one? Oh, yeah. What did you do for this? Oh my God. No, fuck that. A segment tree, really? Wow. Yeah, talk about overthinking. Damn. I have the benefit of seeing. I like immediately. Let me see if I can find it. I can just immediately see like, oh, 6,000 people. It's going to be not hard. And I know exactly what my that would have been. My severely overthinking it and getting fucked thing. Because it's kind of saying like, you have some wobbly thing here and you need to like hold it down by like, this needs to be that at most. And this needs to be that at most. Therefore, like, there's going to be some linear relationship where this goes up like that and this goes up like that. If it was a more difficult problem, there could be like many of these. And these could be like a huge distance away. And then you would actually need to solve some like annoying linear equation here. I would find that very frustrating. And I was like, maybe I'll do it that way. No, I'll do it a really simple way. I saw that seg tree solution, so I went with that, but it was too slow and I only optimized it enough after the contest. Oof, that's rough. I feel like after 20 minutes of trying that, I would be like, is this real? Especially if I saw this number count up above like 500, I'd be like, is this really what they intended? What's the daily? Is your simple solution? Yeah. Yeah, it's like that kind of problem, I guess. I did that first, but just greedy one way can't work, right? Yeah, I think you just do it both ways. But whatever. There's like 101 string problems like that they used to upload on Leetcode back in like 2018. Given an integer array nums, find the return the sum of divisors of integers in that array that have exactly 4 divisors. Interesting. Okay. Exactly 4 divisors. Well, you'll always have 1 and yourself, right? So then you need to either be the multiple of 2 primes. You need to be the multiple of 2 primes. There's no getting around it, right? So how would you find that out efficiently? I first used a Fenwick tree in lieu of prefix sum, but it was too slow. Yeah, it would have been interesting if they'd asked like anything in a radius at all, like not just the you can only hop to the next row thing. Where is this? Man, that feels bad. What happened? I just got so many fucking errors on that last one. That was really sloppy. I only had 3, actually. That's not as many as I thought. This error was tragic. This error was so stupid. It was just the, oh, if it's not valid, return -1, which like I feel like they don't do on Codeforces. This problem, I think this problem would have been way more of a headache than it already was if they didn't have this. If you could just move to any row above this, like then it would be pretty difficult. Because I think you wouldn't be able to isolate by row. You'd have to do this moving prefix thing in 2 dimensions instead of 1, which would be kind of cool. But, I mean, already, if 620 people got this, I don't think you need to make it more difficult. Let's see. Okay, sum of 4 divisors. So this is saying 20... Wait, what am I doing? Return the sum of divisors of the integers in that array. So the only answer is 21. So how do you find that? Did I use 2 pointers for Q2? Yeah, I did. Yeah. I thought momentarily about a binary search, and then I was like, I think I'm way overthinking this. Because like this is, it's a stronger statement to say that this function on a subarray is completely monotonic with regard to the length. No matter what you do, if you increase the right bound, it will go up, and if you decrease the left bound, it will go down or stay the same for both of those. which is... I actually can't really think of a situation where you would want to binary search and a two-pointer approach like this wouldn't work. Like, what would that look like? If you couldn't do a two-pointer, but you had to binary search. I don't know. It's possible when the left of every right isn't increasing. If I can do both, I prefer binary search. It's easier to implement without bugs. I don't mind this. Yeah, I hear you. I think especially coming from C++, like using this weird counter logic constantly feels kind of bad, but... Okay, I'm actually kind of curious about this. For divisors. So one thing you could do is implement a sieve. And I think if you do it right... Is it linear? I don't think there's any getting above linear. No, maybe there is. Because nums at I is 10 to the 5th. So this is like log x is one option. Log n would be better than that in theory. But I'm only saying that. No, that's weird logic. Let's see. You could do a sieve. You could do a prefix sum on each sieve. And then you could find each answer in O of 1, basically. Or it would be O of n. How does that work? No. I don't think you can get away with a linear sieve. I think you would need an n log n sieve. And at the point where you're doing like n log n here, I think there's better ways to do that. Right? But it's still doing it once. You've pre-computed it. And then you never have to do it again. Okay, I'll look at that in a moment. Sieve is equal to that for blank in range. That. Okay. And then this is going to contain all the primes. So sieve at 0 equal... no, those don't matter. So I'll say for I in range 2, that. For I in range 2, that, if sieve at I, continue, sieve at I, no, I'll say, sieve at I dot append 1, sieve at I equals accumulate sieve at I. That's really sloppy. That's such a weird way to write that. I'm just gonna say val is equal to that. And then I can just say val at I equals sum sieve at I. Okay, sieve at I dot append 1 for j in range I lim I sieve at j dot append I. So then each element is going to have, it's going to be the sum of all of its prime divisors. Wait, what if a number is a cube? That also works though. Shit. Right, if you had 8, you have 8, 4, 2, and 1. So you need the cube of a prime or a composite of 2 primes. But I'll deal with the composite of 2 primes first. And then actually it's going to be really easy. I can just say sieve at how do I want to do this? So this is going to say you're going to get to 2 and you're going to fill up 4, 6, 8, all that. And then you're going to get to 4. And before you say if sieve at I continue, or while you say this, I think you would want to say if sieve at I, If the length of this is 1, you know that this is a prime squared, right? So then you could say sieve at I times, this is very weird, sieve at I at 0 dot append I. So you're saying if I get to a 4, that's 2 squared. I want to append that to an 8. So yeah, like 8 is going to have, instead of just a 1 and a 2, things are going to contain prime factors and squares of prime factors. And there's no point to having primes contain themselves. Let's see, val at I think I'm just going to do that in a separate loop. Val at I is that. Yeah, val at I is that plus I. And then this is going to be if length of sieve at I is equal to 4. And then here I can just say return sum map val.getItem A. And it should wind up working eventually. If length of sieve at I equals 1, sieve at I times sieve at I see. I need to say and I times sieve at I at 0 is less than the limit. So let's see what sieve at 21 is coming up with. It's saying 3 and 7. Yeah, okay. It's because it's not including 1 and itself. So, man, this is getting a little sloppy, but that's okay. So include 1 and yourself in everything. Include primes and include squares of primes, right? Shit, now it's just 1 and 21. Oh, it's because right here I say if sieve at I is greater than 2. Right? And if it's exactly 2, then it's just 1 in itself. Okay, there we go. Simple little O of n one-liner. It does have this weird O of n log n pre-compute. That doesn't really feel great, but whatever. What went wrong here? 19. So I included a number I shouldn't have included. I see you. I know. Give me 10 more minutes, okay? And then we'll go outside. You give me 10 more minutes and we'll go outside, okay? Good boy. You go lay down. X and sieve at X. 9146. In what world could I possibly get to that number? That seems very odd. $19,416 compared to 10,932. Neither of those numbers seem plausible to me. I think that that tells me that I'm probably not going high enough. But I don't know why that would matter. Nums at I is 10 to the 5th. I guess as a quick test, 2 times 7 times 167. Okay, so I'm clearly missing. All right, fuck it, whatever. We'll just get rid of this. If length of sieve at I We'll keep this one. And then it'll just be all of the factors. Because I think otherwise it's fucking up. Yeah. Which is fine. I was trying to do something kind of cheeky, but I think it was not worth it. One, two, three, four, five, six, seven, eight, nine, 10. So what would you include here? You would include 8, you would include 10, and you would include 6, right? One, two, four, four. Oh, this is not necessary now. All right. Whatever. Kth smallest path XOR sum. I know. I was trying to do some cheeky way to do that. I feel like that did not really work out. If this is in your attempt at all, keep it. You're given an undirected tree rooted at node 0 with n nodes numbered 0 to n-1. Each node I has an integer value vals at I, and its parent is given by parent at I. The path XOR sum from the root to a node U is defined as the bitwise XOR of all vals at I for nodes I on the path. The bitwise XOR. Okay, wait. Yeah, okay. You're given a 2D integer array queries where queries U and K. For each query, find the kth smallest distinct path XOR sum among all nodes in the subtree rooted at U. Ah, okay. If there are fewer than K sub J distinct path XOR sums in that subtree, then the answer is -1. So you need to find the... Yeah, I already did this one, I guess. You need to find the kth smallest XOR path in a given subtree from the root to that. The constraints look not the most forgiving, so you can't just like brute force it. Oh, yeah, okay. So you would just use like a binary try, right? For problems that are like, what's the minimum thing that's XORed with this? Normally, if it's just what's the minimum number, you're just like, okay, well, let's just compare all of them. But if it's what's the minimum thing XORed with this, then you can use a binary try to get that, right? Yeah. Don't you just do like a prefix minimum up the tree? And you're like, for a given subtree of the binary try, that's going to be the minimum number among all the suffixes that contain this prefix. Or wait, no. That's going to get you the minimum with a prefix. What was the idea behind a binary try? Does that have any merit? I never did binary try, and that's why it's not that complicated. It feels cool like digit DP, but it's a lot simpler than that. It's just like a normal try, but binary-ish. What's my plan here? What did I do? Okay, I didn't do a binary try. That was wrong. Oh, wait, yeah. Okay, Okay, yeah, you have to be smart about it. This is like, yeah, you do it offline upwards. That's what you do. Probably worth me redoing this one. So you'd say handle all queries in this sub tree. It's getting dark in here. Well, I'm going to go in a minute, but handle all queries in this subtree. You can find for any given subtree the prefix XOR, right? So you'd say, what are all the values in this subtree given this XOR? Take the minimum. Yeah. The fact is XOR is irrelevant then. Well, I guess I gotta hand it to him for having a red herring. I don't know. All right. That's kind of nice. I haven't done Leetcode contests in months. It was a rough return. Well, this one was. I don't know how that would impact my rating, but the previous one felt kind of good, I guess. Especially because this is pre-purge. All the cheaters haven't been purged yet. Oh. Yeah. Should I go back and do these? I don't really... I'll do them, I guess, quickly, but I don't really... Well, maybe I won't do this. But I don't really trust that I'm going to keep my streak. You have a grid of size n by 3, and you want to paint each... blah, blah, blah. No cells that share vertical or horizontal sides have the same color. Given n, the number of rows in the grid, return the number of ways you can paint this grid. Okay. This seems like maybe I could do this in a matter of a few minutes. So you're going to have a mask that is, what if you painted this grid with this mask? Solve it. Yeah, that's the goal. You're going to have a mask. So, there's just a certain number of valid masks, right? And that's going to be 27. There's 27 masks. Only some of those are valid. So you would start with that. And then you would say for every mask, I guess there's 12 valid masks, right? For every valid mask, how does it relate to another valid mask? And I would guess that each valid mask relates to just a certain number of other valid masks, right? So if we had n equals 2, like what would the answer be? Like red, 0, red, red, yellow, red is going to relate to like yellow, red, yellow, or I guess anything that doesn't have red here, doesn't have yellow here, and doesn't have red here. So how many things don't have red here? 8 things don't have red there. How many things don't have yellow here? 8 things, presumably. 1, 2, 3, 4. Is that true? No, I guess 12. Yeah, 8 things. Yeah. And then how many things don't have red here? Also 8 things. But I think a better way to put it is of the things that don't have red here, how many things don't have yellow here? It should be 4 things. Right? There's 8 things that don't have red here. No, 6. Then there's 6 things that don't have yellow. And then of those, how many don't have red here? 5? right? So that almost tells me that for any given color, you're just exactly going to have 5 other colors that work. So if I try that real quick, like what happens if I just say return that? No. Oh wait, no. What happened here? Why is this 5,000? No, still doesn't work. Are you doing the first Codeforces contest of 2026? Probably not, no. I got stuff I gotta study for. This stream is almost me putting that off, honestly. You would think when n is 1,000, it would be astronomical. So why is this only 1, 2, 3, 4, 5, 6, 7, 8 digits? No, that seems normal. Why is mine so big? Oh. There we go. No. Still doesn't work. So I think there's a flaw in my logic. My thought process is that for every one of them, there's only 5 other things that work. I mean, I guess I could just test it by like, what happens if n is 2? By my logic, there should be 60 possible ways to do it. Yeah. Okay. And I'm getting it wrong for some reason. Wait, what? No, expected is 54. Okay. So why would that be? What are the 6 that don't work? That's a little bit sucky because the fact that this is not 60, it's 54, tells me that it's not going to be as simple as just like the power of a number. I feel like it almost is, but not quite. I don't really want to like binary lift the state space. I would really rather just do it mathematically. That seems a lot more clean. But maybe you have to. Maybe like, is there anything that differentiates red, yellow, red from red, yellow, green? If I do this, this should also just have 5 things that it relates to, right? Nothing with red, so you're immediately choosing from these 8. Nothing with yellow, so you're immediately choosing from these 6. And nothing with green, so you're choosing from these 4. Wait. Huh. Why? Okay. Why for red, yellow, red are there 5? And red, yellow, green are there 4? What's the logic there? Well, whatever. I guess that means if they're the same, they connect to 5 things. If they're if the 2 ends are different, they connect to 4 things. So with that in mind, it feels like, all right, you could do like the exponent of a translation matrix, right? It's kind of annoying, but So it's going to be, okay, if both of them are the same, how many things does it relate to of these 5 things it relates to that are, how many things does it relate to that are also have 2 ends that are the same? I think 3, 2. Yellow, red, yellow. Green, red, green. And yellow, green, yellow. So 3. So I'll say there are 3 things that... There are 3 ways for the 2 endpoints being the same to translate into another thing where both endpoints are the same. That means there's 2 ways for the opposite to be true, and then I would imagine it's the opposite, so 2, 3. If all 3 are different, no, it's not going to be the opposite, but it's going to be close. It's probably going to be 2, 2 would be my guess. If you have red, yellow, green, then you can translate into one, 2 ways for them to be the same, and 2 ways for them to be different. So 2, 2. Okay, and then I just need to do some sort of like NumPy magic here. Let's see. I want that. And then I'm going to multiply this by 1, 2, 3, 4, 5, 6. So there's 6 different ways for them to be the same and 6 different ways for them to be different. So state is going to be equal to 6, 6. How do you exponentiate a matrix again? I forgot. You just multiply them by themselves, right? Okay. So I'll do binary exponentiation, or else what's the point? So res is equal to np dot, I think you can just do dot identity. Yeah. Identity 2. I don't think I need to. No, this is overthinking it. I can just do it here logarithmically. So res is that while n goes down, trans is trans at trans for the transformation if n and 1 fuck. Oh. $30 is not a valid value for the expected return type integer. Sounds good to me, but okay. I think first things first, I want to say n minus equals 1. I don't know why I said 6 comma 0. Okay, 12, 54. This is off, which is interesting. I wonder if that has to do with... I bet that has to do with floating point arithmetic. Okay, well then I'm not going to use NP arrays. I don't care about that. I'll say if n and 1 is there an easy way to just percent mod? No, that's fine, that's fine. Because I think I can say make them an int. They require a thick size. I see. That's okay. Can I do that? Will it be happy about that? It will be happy about that. So then I can say there we go. Okay. Now it doesn't really matter that they're not native ints because it'll work out. Okay. And this should just straight up be O of log n. Nice. All right, well, that's it for me. It's kind of fun. Did I already do this, or? Oh, this is like ancient code. Interesting. All right, well, I'll deal with that later. Maybe next time. Okay, thank you for watching. See you guys.